be a structure by itself. If we plot this graph here, deflection, okay, column, and this is P, yeah, okay. So an imperfect column, it will, right from the beginning, it will bend. I mean, right from beginning, delta will become non-zero. Okay. So this is similar to the graph that we already draw. So when you apply loading, when you go up this axis, when you apply loading, you already get delta will be non-zero, but then it will slowly become like this, but it can never cross the line, okay? Can never cross the line. So this is imperfect. Now, if I ask you to draw the behavior of the perfect one, where is this? The behavior of the perfect one. Where are you going to draw a line similar like this? Perfect. This is imperfect is here. Okay, I use it in different color here, imperfect. Using the same graph, if it is a perfect one, where is this line? Where is this line? Up where? I have to up, or is this up this curve means if you draw here, perfect one. Where is the perfect one? Where is the corresponding curve if I ask you to draw the perfect one? Is it here, here, here? It looks like. Where is that line for the perfect? Where is that line that I should draw here for the perfect? So it will be not this, because the perfect one, remember class perfect, it is perfectly straight. So when you apply loading, it will remain straight. It will remain straight. Remain straight means delta zero. It will remain straight means delta zero. For imperfect one, right from the beginning, as long as you apply loading, it will bend, mean delta non-zero. That's why we have this. So based on that, the perfect one, the delta must be zero. When the P increase, so the graph follow this. It follow this, okay? This is a perfect one, it follow this axis. Because when you perfect one, and you apply the loading, there is no delta. But if you disturb this, any of the shape here, the straight one, which is below P critical, if you disturb it, then it will go up here and there. Finally, it will come back to this shape. Okay? If it is below P critical. So the shape here is stable. Okay? So you disturb it, it might come here, it might go there, and then finally it goes back to the straight one. So the straight one here is the stable. So if you, the answer to the question that I asked is, if I ask you to draw the corresponding curve representing the behavior of perfect column is this one. Okay. Now, when it reach here, what happened? This is a revision of what you already learned. When it reached here, what happened? This point here. For imperfect, it can never reach that level. For perfect one, it will, when it reached to this level, what happened to that perfect column? When it reached that point there, which is exactly P is equal to P critical, what will happen to that column if you disturb it? Is neutral. At this particular state, it is neutral, which means this one, if you disturb it, it can also take this shape. So both shape is possible. So at neutral one, you can two shape is possible, the straight one and the slightly bent one at this point. If you go up further, what happens? Go up further. Go up further, what happens? Bend. It will bend. If you go up further, this straight one already unstable. It's already unstable. If you disturb it, it surely has to bend. Okay. So this is the only possible shape. So a proper understanding, with proper understanding, if I ask you to show the behavior, the curve representing the perfect and imperfect system on the graph like this is what you should draw. Okay. Imperfect one, immediately you apply loading, it will bend, which means it will follow this curve. It will follow that curve. Okay. And then the perfect one will follow this curve. Right until this point here. Okay. At this point, it has, at this point here, in this part here, only the straight one is possible. It will remain always delta 0. But at this point here, if you disturb it, remember class, for perfect one, if you don't disturb, you cannot get anything. You have to disturb it. If you disturb it, then it can stay in this shape. It can also stay in the straight one. This is neutral. Okay. This is neutral at this particular point. This is neutral. Then when it goes there, the straight one already unstable, it has to bend. So here, the straight one is stable. Here, the straight one is neutral. Here, the straight one becomes unstable. It has to bend if you disturb it. Okay. So that is to differentiate between perfect and imperfect using this diagram. Okay. Now, what is the name of this point? This is to give you some hint if I ask you in the test. What is the name of this point? What is the name of that point? There's a special name for that. Yeah. This particular point here, exactly on this vertical axis, exactly when P is equal to P critical, there's a name for that. There's a name for that. This point here, we call it bifurcation point. Okay, it can bifurcate. Here come, it can go this way, it can go that way. For perfect system, it's a bifurcation point. Okay. So I would like to end here by saying that bifurcation point, okay, which is lying on this axis here, is only possible in perfect system. It's only possible in perfect system. We cannot get in perfect system a column can stay the straight one and slightly bend one. That is impossible. Okay, because imperfect system always you have imperfections. Once you have imperfections, you already disturbed. Okay? So bifurcation point and concept of neutral equilibrium is only for perfect system. Perfect. Why? Because imagine, can we have a column in the actual one? If you disturb it, it can slightly bend. The straight one also possible. For an actual column, we can take two shapes. That is impossible. In the actual one, structure will always look for stable shape. In the actual one, structure will always look for stable shape. Unstable, it cannot maintain unstable shape. Because any small disturbance, it will go to other shape. Okay? So the concept of neutral equilibrium is only for perfect system. Okay? But it is useful for us to differentiate, to give a definition of P critical. This is very useful. Okay? But it is only for perfect system. And also because this point lies on this axis, which is representing the behavior of perfect system, bifurcation point is only for perfect system. Okay? So that is the important thing when if you are doing later your research project in stability. So these are the things that I hope you understand. If you do experiment, why the curve that you get is like this, and why they suddenly increase like this is because especially for structure which is in compression, if you do the experiment, then you are going to get a result like this, suddenly very small, suddenly increase. Because that is the typical behavior of a structure where the load is already close to imperfect, close to the P critical. Okay? So my plan is and when you go to the lab to see this actual behavior of a compression member where you can really see this phenomena. When the load is very small, you don't see anything. When you increase the load, suddenly that member deflects. This actually we can see. Okay. So that is the things that is explained there in the notes. Okay. And that is what I want to cover today. Okay, about the imperfect behavior. Okay. Now before I end, I want to demonstrate to you something, but the other side I cannot see. And to ask you if this is perfect or imperfect. Yeah? I want to demonstrate to you something. See. I want to show to you is this. This is powder. I have this. What I want to do is, I think maybe you have seen this. Like this, stand up. Okay. Blow. Now, to end this is unstable or this is neutral? This is unstable or neutral. This is in equilibrium. Okay. So this state here is neutral or unstable. Unstable. Okay. Neutral. Okay. Stable. Okay. So what is the definition of neutral? Two possibility. Okay. Yes. Yes. Yeah. Neutral means two configuration is possible. Meaning that if I disturb this, the egg can, if I disturb this, the egg can stay like this, which is the straight one, and it can also stay like this. That is neutral. Okay. Unstable means if I disturb this, it cannot stay like this. Neutral means if I disturb this, but disturb slightly, the eggs can, it will not fall down. That is neutral. Stable means if you disturb it, the eggs will, if I disturb it, the eggs will like that, it will stay back like this. That is stable. Okay. Unstable means it will not go back to this state. Okay. So I ask again, this is stable, unstable, or neutral? This is unstable here. Okay. Anyone say this is neutral? Neutral? Is it neutral? Okay. Neutral? Unstable? Stable? Okay. Now you don't get, I want to ask one more time. This is in equilibrium. Okay. Stability is to explain the state of this equilibrium. So you have to get it correct. This is in equilibrium, there's no doubt. The load's coming down because you have a reaction there, so it is in equilibrium. But now we want to give another explanation. The state of this equilibrium, is it stable, unstable, or neutral? That is the state of this equilibrium. Okay. Now, to answer this is stable, unstable, or neutral, you must go back to the definitions. Stable means the phenomena is I disturb this, the X will stay like that. It won't fall down. It will stay like this, upright. Neutral means if I disturb it, it will not go like this, it will like this. That is neutral. Unstable means if you disturb it, it will not stand up like this, it will fall down. Most likely it will lie down. Okay, so that is the meaning. So one more time I ask, stable, unstable, or neutral? Unstable, unstable. Neutral, neutral. Unstable, unstable. So now that disturb this now, yeah? Disturb, just slight disturbance only. Slight disturbance. Neutral means it will go like that. It's slight disturbance. So this is unstable. Neutral cannot be, because neutral means if I disturb this, it will stay like that. The egg cannot stay like that. Okay? Because you disturb this, it will go to like this. When you go to like this, means this is go to some equilibrium shape, which is far away from this shape. So this is what I do just now is unstable. Okay. In practice, in actual things, it's almost impossible to get neutral. Impossible, neutral. So stable or unstable. If any structure, which is any structure that we see can stand up because it is stable. It is stable equilibrium. If unstable, surely you will already go to other shape. Okay. So I have been practicing this for more than 2 months. Finally, I show to you in 5 minutes, so I'm very happy. Okay. The reason why we put this is without this, it's difficult to stand up the egg. Without this powder, very difficult to stand the egg. You stand the egg first, then you blow away, then the egg can stand. Okay. So when you have time, when you are feeling very stressed, please try this out. Okay. And this egg is don't have to cook or don't cook, doesn't matter. Any eggs can be used, I think. Okay. Yeah. Okay, that's all, class. I will finish lectures today. Okay. On Thursday, it starts on 12. Okay, Thursday we start on 12. I might. Please refer to this e-learning. I might give you some things to do on that first hour. Okay. Okay. So thank you very much, all class. Okay. All right.
这个鸡蛋生的还是熟的？
生的，
回家还可以吃呢。
不知道可以生吗？生的，不是熟的。我想把生还是熟的没有关系，因为它这个 shape 它一定是 non-stable，生跟熟没关系的，都不重要。